So when you go back to this tangent graph, once again, the first thing you're going to do is label out A, B's, H's, and K's. In this case here, the coefficient of the x value in the parentheses is 1, so it's not being a sneakerson. How do I screw that up? So do we agree that there are A, B, H's, and K's? All right. Next thing you do is figure out your period. Your period here is just going to be pi. Notice that your A value is negative, so it's going to be going from left to right, decreasing. So now we have to figure out our asymptotes. Where's your original parent asymptotes going to be at for this one if the period is pi?
It's okay, you can say it. Throw it at somebody, you'll be fine.
So your asymptotes for the original graph are going to wind up in plus or minus pi over 2. So you start by graphing. I know that I'm going to have to move this to the left and up when I'm done with this. So I'm just going to kind of move this over here a little bit and maybe lower it down. Maybe extend it over to the left some, just to give yourself some space. Draw on your asymptotes. Pi over 2, negative pi over 2. I know my original graph is going to go through the origin, so I got to find my halfway points. Halfway between 0 and pi over 2 is 4. And then negative pi over 4. Since the A value is negative, we start at the top, work our way down. Okay. From there, I list out my stuff. Then negative pi over 4, 1, 0, 0, pi over 4, and negative 1. Obviously, our asymptotes are at x equals negative pi over 2 and pi over 2. So now I'm going to do the shift on the graph this time instead of do my ordered pairs first. Seems like, I think most of you guys probably do it that way anyway. Whatever. So when I shift these things, I'm shifting everything to the right, pi over 2. I always start with my asymptotes. So if I move pi over 2 to the left, where does it wind up? Pi. So it's negative pi. If I move positive pi over 2 to the left, pi over 2, where does it wind up? 0. Those are my two new asymptotes. If I move the 0, 0 point left, it winds up at negative pi over 2. Then it has to go up 2. So it winds up here. So now I know that my first point, when I move it, is at negative pi over 2 and 2. My asymptotes are at negative pi and 0. Okay, I plotted them, I'm just writing them down. When I move negative pi over 4 to the left, negative pi over 2, it winds up at negative 3 pi over 4, very good. And since the original point was at 1, it is now at 3. And then lastly, when I move pi over 4 over pi over 2 to the left, it winds up at negative pi over 4. And then it just goes up 2, so now it's at 1. Parker's dead as well. And now you just connect dots. There you go. What's that? You're about to sneeze, so bless you. Now you won't sneeze. I thought you said you swallowed your finger. I'm like, what? Yeah, it's usually if you're eating, you're not going to sneeze. So, okay. You got that going for you. Which is kind of weird. You can't walk around like this, though. Well, you're sitting next to eating. What else we got, guys? Are there any others on this you want to double check? Are you okay with signs? Or excuse me, with tangents? All right. Make sure your names are on this because I want to go over with you guys a couple of the other tricks.
Oh my god.
Yes, I know. When we get into the first part of the test for tomorrow, what's going to happen that's going to be on there is going to be identifying your periods and amplitudes, and then you're going to have to graph sine, cosine, and tangent. Now, when you're graphing sine, cosine, and tangents, all of them are going to have shifts. Left, right, up, down, something like that. They're going to have to shift to them, which means just like we've been doing in class, where I'm going to ask you to identify your original ordered pairs, your shifted ordered pairs, your A, B, H. It's spelled out in such a way that if you're doing the homework, like I'm doing the problems on the board and everything, it's just gonna feel like normal. All right, just like a regular problem. But one of the things that students have tendency to mess up is when that hidden value within the parentheses, when you're dealing with your amplitudes and your periods here. That's usually where people mess up. That one tangent problem was at number 49, where you had to factor that out. Or the other thing is people tend to mess up is when they ask you amplitude and period of something like this. 1/4 sine 2/3 pi x. When I ask you to find the amplitude and period of that problem, a lot of people tend to freak out. So when you look at that, is there an H or a K in this? No. All you have is an A and a B, right? All right, what's your A value? A is 1/4. What's your B value? 2/3 pi. So 2 pi over 3, if you want to call it. You agree? All right. From there, what's your amplitude? 1/4. Okay. So your amplitude is 1/4. How do you find the period for a sine function? 2 pi over b. So that means you have 2 pi divided by 2 pi over 3. Now everybody stop thinking for a second, clear your brains. This is where people tend to mess up when you get into this complex fraction. And you're going to see more and more complex fractions the second half of this chapter, especially in section 14.3. So I want to revisit to you what that means, because you're going to see it tomorrow. Remember, this means the exact same thing as 2 pi divided by 2 pi over 3. Do you agree? When you are dividing by a fraction, you multiply by the reciprocal. We're not cross-multiplying, remember, there's no equal sign. You multiply by the reciprocal, so you get 2 pi times 3 over 2 pi. What's your period? 3. Is it okay to have 3 as a period? Does it matter that there's no pi involved? Could you still graph that? Absolutely. If you still had to graph that, it's a sine function. Remember, sine functions end at the period. It starts at the origin. What's halfway between 0 and 3? What's halfway between 0 and 1.5. What's halfway between $1.50 and $3? Is it okay that you do that numerically with the decimal and not have to worry about having pi in the answer? It still looks the same. Your A value is 1/4. So the opposite A is -1/4. Now sign, when you start at 0, is sign at 0, 0, or is sign going to be at 0 and the A value? Then where? Does it go to the A or the opposite A? Goes A. So I still get a sine curve. Oops. Kinda. I still get a sine curve even though I'm kind of rational numbered in integer value without pi. Okay? It works. It still works the same. Students have a tendency to freak out when they see that because the pi's go away. Remember, when you're doing this, rewrite it horizontally. Multiply by the reciprocal, and it will help you out tremendously. Okay? You will see stuff like that. You just got to make sure you identify that. All right? I'm going to do another example where you have that sneaky x value in here, because I had forgotten to press record on the review part of tangent, just so you guys see that again. Questions about this and how you work with that complex fraction, or is that okay? Well, everybody does that. So. All right, look at this one then. Let's say we have y equals 2 minus sine of and I want to graph that. Do I have that already written out in the standard form for sine? No, because there's that x value has a coefficient that's not equal to 1. So what do you have to factor out of it? A 4. Good. So when you factor out of a 4 out of this, you get y equals 2 minus sine of 4 parentheses x minus what? Excellent. All right. Now, can you identify your A, B, H, and K? Yeah. All right. Graph that one. Take a minute and graph that one. We'll check it in a second.
Okay, so do you want us to write down the new asymptotes, like, or just draw them?
You'll have to write them down.
You have to write down the new. So I would.
The sine function doesn't have asymptotes.
Yeah, I know.
Okay, just make sure. Change this up, yeah. Just like we did, just like I always do. I always rewrite it. All right, guys, I'm going to start walking through this one, so please quiet down for a sec here. Remember, you always start out the same way. A is -1. B is now 4. H is pi over 4. And K is 2. So for every one of these points, I'm going to have to go to the right, pi over 4, and up 2. Remember that a sine function has the amplitude is going to be 1, absolute value of A. My period is going to be 2 pi over B, so it's going to be pi over 2. So here's my pi over 2, pi over 4. This would be pi over 8. And this would be 3 pi over 8. Okay? My A values are 1, -1. And when I start this curve out, since the A value is negative, do I go up first or down first? Down. Very good. I go down, up, down. Now I have my ordered pairs. Mark it over there. So we're at 0, 0, pi over 8, negative 1, 0. Oh. How did I not have an eraser on that side? This is pi over 4, 0, 3 pi over 8, positive 1, and pi over 2, back to 0. When I go to shift all of my points, I'm adding to the x coordinates pi over 4, and I'm adding to the y coordinates 2. So your shift is plus pi over 4 and plus 2. So it's pi over 4 and 2. When I add pi over 4 to pi over 8, you get 3 pi over 8 and 1. You add pi over 4 to pi over 4, you get pi over 2, very good, and 2. Here you're going to get 5 pi over 8 and 3. And here you get 3 pi over 4 and 2. Now, once again, when you're dealing with weird fractions, everybody see how I gave you one that has eighths and quarters and stuff like that? It might be easier to do this stuff first when you have the weirder fractions. If it's going up by a quarter or whatnot, or it's sometimes a little bit cleaner to go right to the graph, but there's nothing wrong with labeling out your points first. Sometimes it's easier for people to do that. So here when I do that, I start to relabel. Pi over 4 and 2. 3 pi over 8 and 1. Pi over 2 and 2. New one will be at 5 pi over 8. And it's up here at 3. And then the last one is at 3 pi over 4. And it's back at 2. So a new graph looks like this. And that's one cycle of pi, or one cycle of sine curve here. Okay? Do you guys get that okay?
Yeah.
In your mind, right?
I wrote it out. You can look at it.
Other than that, there's really, like I've said, I wanted to take these first two sections and make sure that we were extra thorough on it. Because I feel that, correct me if I'm wrong, it seems like this isn't as bad as what we've been doing. Okay. Because whereas the other stuff is as important, I want to make sure you guys kind of help yourselves out a little bit here. That's why I slowed down. Okay? That's why I slowed this stuff down. That's why I'm splitting this chapter into 2. That way you guys can benefit from a better grade tomorrow. Okay? So, suggestion for this evening. Don't study, yeah. Don't study, that'd be smart. I'm giving you guys some time right now to look at some stuff. Don't worry about this. On page 959, the chapter 14 stuff, I would definitely be looking at those. And we've got, what, 5-10 minutes, something like that? All right. And open up the book right now and start looking at them. See if there's something that you know that you're going to have a heck of a time trying to solve. And ask about it now. Because, of course, there's no flex today. So, all right. I'm not going to collect it. It's just review. It's extra problems that we haven't seen yet. So I think as of right now, we've done just about every single one of them in the book except for these. Okay? Now, I recorded all this. I'll